Hello guys, welcome back to my channel. Today we're going to be looking at how we actually draw what is called a cumulative frequency curve. Now to do that, let me just quickly move this out of the way. All right, there we go. All right, it says the table below shows the amount to the nearest dollar spent by a group of 40 students at the school canteen during a period of 1 week. All right, and we're going to be using this information to draw our cumulative frequency curve. Now, to draw a cumulative frequency curve, we need the upper boundaries on the x-axis and the cumulative frequency on the y-axis. Now, let's start with the cumulative frequency. How do we come by this? As the word suggests, we accumulate the frequency. So we start off with the frequency, which is 3. We have 3 over here. Then to get 10, we go 3 plus 7 is 10. To get 19, the 10 that we have here, we add it to the next frequency, which is 9, and we get 19. Now, to get my next frequency, it's going to be 19 plus the frequency that comes after, 19 plus 11, which is going to give me 30. Now, my next frequency, my next cumulative frequency, that is 30 plus 8. By the way, the number of students here is the same thing as saying frequency. All right, a very important point to note. Now, 30 plus 8 is going to give me 38, and then 38 plus 2 is 40. If we want to ensure that this column is correct, we simply add all the numbers here, and we should get 40. All right, there we have it. So I know that my cumulative frequency down here is 40, and my total frequency will also be 40. Now, let's say I decide to go up on the x-axis, on the y-axis first, because the cumulative frequency goes on the y-axis. So we need to label our axes, make sure we have y up here, and make sure we have x over here, where we have the x. Okay, let's go up now. Now, since the cumulative frequency go up there, I could probably go by 10. So I'm gonna have 10, 20, 30, 40. We need to use up at least 60% of our graph paper, right? Now I'm just using parts because I have things all over the place on this graph paper, but at least 60%. So it's 10, 20, 30, 40, 50. All right, let's say we go up to that point. Now, on the x-axis, I'm going to have my upper boundary. Now, there are several ways to do it. All right, we can go by uniform numbers that would make things easier to find. So, for example, I could go 10, 20, 30, 40, 50, 60. Now, what some persons do to make the graph easier to draw, they simply plot the upper boundaries. For example, to get upper boundaries, we add 0.5 to the upper class limit. The upper class limit would be 10, 20, 30, 40, 50, 60. 1, 11, 21, 31, 41, 51 are called lower class limits, and each group is called a class. 1 to 10 is the first class, 11 to 10, second class, 21 to 30, third class. All right. Now, I'm going to do 2 examples, but my first example is I'm going to plot it using the upper boundary. All right. So I could probably start here. Here I'm going to have 10.5. And then I'm going to have 20.5. I'm going to have 30.5. Then I'm going to have 40.5. Okay, let me write this properly so we can all see it. So we have 40.5, we have 50.5, we have 60.5, so I could probably carry this up to 70.5, right? I'm gonna put my X here. And remember, at least 60% of your graph papers, I'm saying I have information here, so now I'm gonna stop where you can actually see the graph. Now down here, this is the amount of money spent, I need to put that there. Amount of money spent, right? This is in dollars. On the left here, on the y-axis, we have what is called the cumulative frequency. Eventually, you're going to need a tighten a scale, all right? But let's leave that for later. So we plot the upper boundary against the cumulative frequency. That is important. Now, the scale that you use is also important because when I go up now, I know that there are 10 lines here, so each line represents 1, so it's easy to find. So when I'm looking for 10.5, which I have on the graph, and I have the cumulative frequency being 3, I just simply look for 10.5 and count 3 little lines going up. So 1, 2, 3. I'm going to put my point there. Now don't make your point too big. Then I'm going to have 20.5. Now remember, add 0.5 to the upper limits. 0.5, 0.5, 0.5, 0.5. 20.5 to 10. 20.5, 10. The number is on the left, so that's easy to find. Then I'm going to have 30.5 to 19. 30.5, I go up. 19, since the little lines represent 1, 19 is 1 just before 20. Then I'm going to have 40.5 to 30. So 40.5, I'm going all the way up to 30. I'm going to put my dots here. Then I'm going to have 50.5 to 38. 50.5, I'm going up to 40 is up there. 38 is 2 below. Then I'm going to have 60.5 to 40. 60.5. 40 is right here. Okay, now please remember that your line should be, your points should be pretty small. All right, you don't want to have a messy graph. There we go. Now, if you don't like to use the points, you can always use the x's. That works as well. Now, normally, because I'm starting from 0, I don't break the graph, but normally, when we're not starting from 0, like for instance, what if the first boundary was like 154.5? And of course, we normally start the graph at the boundary just before the first of a boundary. So we normally have to pull the graph back down to the x-axis, right? So 0.5 that is. So what we're saying in this case is that if this was, for instance, this little value down here was like 150, all right, we'd probably have to break the graph, start the graph of the 149.5, so we can pull it back down to the x-axis. And that is when we put in a break. But because I'm starting from 0, I don't need to break it. Now your curve needs to be as smooth as possible. Now it's a bit trickier because I'm drawing it on the computer screen, but you have to make it smooth and you have to curve your arm. So you start at a point here, you go through your points, you keep it smooth as possible. Now, when drawing a curve, it's best not to lift the point up. Okay, my bad there. Because normally once you lift up, you normally run into trouble. All right. So let me go again. Because I'm drawing on the screen, I have to move my hand, but now I will just keep it going right down smoothly as possible. And then we'll just pull it back down to the x-axis at the boundary before, which would be 0.5. Now, this is not a perfect curve, but it's a smooth one, all right? Now, my title should be in full caps, all right? So this is a cumulative frequency curve. We also call it an ogive. So ogive showing and it says the amount spent at the school canteen by students. Amount spent. You don't have to have an extensive title. Amount spent by students. All right, now we almost have most of your marks. You must have a scale. On the x-axis, I have 2 centimeters here for every 10.5. So my scale, 2 centimeter to, and 10.5 in this case would be money. So it's $10.50. And then on the y-axis, I have 2 centimeter again. So I'm gonna put on x-axis and on 2 centimeter to 10 units on y-axis. All right, I could have put 10.5 units on the x-axis, but I mean, that's okay there. Now, as we said before, this is just one way of doing it, all right? So we directly plot the upper boundaries on the x-axis. Nothing is wrong with that. Now, there's a lot of things that we can do with this. But before I do anything at all with it, I'm going to erase it and show you the second way of plotting it. So let me just erase all of this right here. Now note that the cumulative frequency is always on the y-axis. No matter what, frequency will be on the y-axis and that won't change. But what I'm going to change here is that I'm going to go up by numbers that are uniform. So when it's time to find different things, it becomes easier because you might have to find information from the graph. So let me go. I'm going up to 60, I'm looking at the boundaries. So I could probably go by 10, still go by 10, instead of going up by 10.5, 10, 20. The importance of this is that when I'm reading information from the graph, it's easier to read. 30, 40, 50, 60, and 70. Now, I know that each small line represents 1 as well. All right, so that makes it easy for me as well. So in between, halfway in between any two lines is a 0.5. So for example, my first upper boundary is 10.5 and my cumulative frequency is 3. So if this is 10 right here, the small lines will be 11, 12. So 10.5 is right in the center. And of course, each little line going up is 1. So I'm going to have 1, 2, 3. So it's going to be dead in the center right there. That's the first point. All right, then you have 20.5 with 10. So I'm going to find 20.5 is in the middle, and I'm going up to 10. So it's dead on in the middle here. All right, then I'm going to have 30.5 with 19. So I'm going to go 30.5 is right in the middle. 19 is just the line before 20. So here we go, dead in the center there. Then I'm going to have 40.5 to 30. 40.5 again is right in the middle there. To 30, I'm going up, all the way up to 30. All right, that's 40.5, 50.5 to 38. So 50.5, going all the way up. This is 40, 38 is still below, right here. Then 60.5 to 40. So 60.5 is in the middle here. I go up to 40 and put a point there. So I know I'm going to have to pull it down to the boundary just before 10.5, and what will come before is 0.5. Well, let me focus on sketching the curve first. So you're trying to make the curve as smooth as possible. All right, and you try to make sure it goes. All right, I don't like how this looks. This part is not smooth at all. Right, and as I said, since you're using graph paper, yours should be even more smoother. Whoa, even more smoother than mine. Let me erase this part right here. All right, it was 20.5 to 10. 20.5 to 10. The point is right there, going right down. And I'm going to pull this down right to 0.5 right there. All right, so here's my curve, right? And of course, remember, I still have money down here in dollars. And that's what my curve would look like. The scale and everything still remains the same. No, the scale doesn't remain the same because on the x-axis now, instead of being 10.5, it's just to 10. All right, now in the next video, I'm going to show you how we use this to find different things like median. So this might just be easier than using the first method. All right.